Hi again, and welcome to Del Mar Learning's Residential Construction Academy for Carpentry. My name's Rodney. In our last program, we prepared an empty lot for construction, determined the location of our house, and completed the layout process. So, with those jobs behind us, the next item on our list is setting the forms. Now, if you don't already know, setting concrete forms are the carpenter's responsibility. We need to make sure that they can withstand a tremendous amount of pressure and can be easily removed for cleanup as well. Understanding the characteristics of concrete is critical to the success of this job, and that includes everything from mixing to handling. Now, I'm going to be throwing a lot of terms at you today, so as we work our way through this lesson, be on the lookout for these important carpentry buzzwords.
Frost line, monolithic slab, reinforced steel, rebars, bar ties, cold joint, bull float, concrete placer. As you can see, our building is completely laid out, so let's set the forms. The first thing we'll need to do is mark the ground with some marking paint or powder. This will form a nice straight line that runs just outside the string. Staying outside of the string is important, because we need to leave enough room to squeeze our forms and stakes in between both the fill and where the concrete will be placed. Once the powder line has been drawn, we can do some excavating for the form boards, and in terms of the process, we have two choices here. It can be done by hand using shovels or with some heavy mechanical equipment. The choice is really yours depending on manpower and cost. In the southernmost part of the United States, monolithic slabs are commonplace. It's a slab with a footing around the perimeter. You'll also hear them referred to as thickened edge slabs. Monolithic slabs use lots of wet concrete, so the actual forming materials must be strong enough to support this kind of pressure. You can use either wood or metal forms. However, if you plan to use wood, I recommend using 2x12 forms supported with 2x2 stakes. When fastening the forms, you'll want to attach them to the stakes at the string height. Remember, you're going to need to disassemble the form boards later. Using 16-penny double-headed nails when fastening the form boards will make your dismantling job go much quicker. How much space you leave for the support stakes really depends on the depth of the footer and the type of soil you're working with. But generally speaking, spacing the stakes about 4 to 6 feet apart will usually give you the support needed to keep your form nice and straight. Holding the form together is extremely important. That means keeping the 2x12 forming materials as flush as possible. Nailing cleats across the splices in the boards will keep your form board nice and uniform. Now, as you continue to build out your form, you'll need to keep the top corner of the form as close as possible to the string line without touching it. If you do, the line will no longer be straight and you'll need to begin all over. You should also check the string. It needs to be nice and tight, and again, nothing should be touching or pushing it out of alignment.
Our form boards are almost in place, but they could still use a little extra support. Remember, when we begin placing the concrete, it's going to exert a great deal of horizontal pressure against the form boards. So we're going to use some diagonal bracing, also known as kickers, to help give us some extra support.
After your forms are in place, fill will be brought in and placed inside the form. Once that's accomplished, you can move ahead and mark out the location of the intersecting walls according to the blueprints. Begin by measuring along the edge of the form boards, making sure to hold the tape on the inside of the forms as you go and not the outside. Why? Because the concrete needs to be placed inside the forms, and if we hold the tape on the outside, we're going to have a lot of explaining to do. When you finish measuring the locations of the intersecting walls, mark them with 2 X's and a B for block. Then, place the string along the measured lines and nail it in place.
After locating and marking our intersecting walls, we can move ahead and determine our pipe locations. By the way, pipes need to be placed inside the wall cavity. That's this area right here in between our two sets of strings. For plumbing and utilities, we'll need to place the pipes and dig the trenches. So let's take a look at our blueprints, find the location of the pipes, and start digging the trenches.
You'll find that some metals don't work well with concrete and will eventually deteriorate over time. So, when we come across one of these metals, we'll simply place sleeves over them in order to prevent corrosion.
Okay, we've installed our pipes, but we haven't covered the trenches with fill yet. Why? Because in some areas, the local building department needs to conduct a thorough inspection before the pipes can be covered.
The overall strength and integrity of concrete is critical, so always make sure that the footer pipes do not pass through the structural part of the concrete. While we're waiting for the pipe inspector, we can go ahead and dig our footers. The footer depth can be found in a typical wall section of the blueprints. The depth of the footer is very important because the frost line varies in different regions of the country. The frost line is the point below the surface at which the ground freezes each winter.
When water freezes, it expands. And if your footings are above the frost line, they're going to heave and buckle when the ground freezes, resulting in lots of headaches for you. Which brings us to a geographical consideration.
If we were constructing our house in the Northeast, our footings would need to be placed at least 44 inches below the surface. However, since our job site happens to be located in a southern climate, our footer depth will be much shorter.
All right, it looks like we're in pretty good shape here, but you should get yourself in the habit of checking your work for accuracy. So, let's turn to our trusty tape measure and check the depth and width of our footer to see if they match our plans.
After we finished with our footers, the pipe inspection was completed, so we'll cover our pipes with fill and tamp them lightly. Don't forget, we have a drainage slope to contend with here, and tamping them lightly will keep our slope intact.
Before we move on, a quick word about termites. Where there's wood, there's often termites. And since termites feed on wood, your construction site could be their next target.
In most cases, a professional pest control operator will come in and treat the soil, with special attention given to those areas where pipes pass through the slab. This creates a nice barrier and should take care of any potential termite problem. With our trenches filled and tamped, we can move ahead and lay down a barrier of polyethylene inside our form. Since our slab is going to be sitting on top of this polyethylene, it should be at least 6 mils thick. In northern climates, polystyrene is also placed under the slab because it provides additional insulation. As we lay down our barrier, we'll make sure to tape the seams and use 6-inch laps. This should prevent the polyethylene from being displaced during placement.
With our polyethylene in place, we can now go ahead and begin to place our reinforcing steel. So what does reinforcing steel have to do with concrete anyway? In a word, a lot. Concrete has what we call high compressive strength, meaning that it's able to resist being crushed. However, its tensile strength, or the ability to resist bending and pulling apart, is rather on the low side. And that's where reinforcing steel comes into play. By placing steel in concrete, we increase its tensile strength and end up with what is known as reinforced concrete.
Okay, let's place some reinforcing steel. But first, we'll need to take a look at our blueprints to see what size steel is needed for this particular job. You'll notice that the steel size is indicated on the plans as a number, which represents 1/8 of an inch. So, for example, if we were going to use number 5 steel, the diameter of the steel would be 5/8 of an inch. Steel is usually rough or deformed rather than smooth, and this is done intentionally because the ridges that you'll see on the surface are designed to increase the bond between the concrete and the steel.
The steel reinforcement we'll be using in this house are called rebars, and in order to determine the number we need, we once again need to consult the blueprints. The number we're looking for should be found in the typical wall section.
Rebars, of course, need to be supported and held in place, and for that we use chair supports, which are usually placed every 4 feet. Once the chairs are in place, the steel is placed gently on them in the bottom of the footer. As you're doing this, keep in mind that your steel must be completely covered with a minimum of 3 inches of concrete. For instance, if the footer is 40 feet long, the steel should be cut to 39 feet 6 inches in order to allow 3 inches of coverage at both ends.
Steel comes in 40-foot lengths. And since all of your pieces won't work out to that exact length, you'll find yourself doing some splicing from time to time. The recommended lapping for splicing is 40 times the diameter of the steel.
So, if you're using number 5 steel, your lap would be 40 times 5/8 of an inch, or 25 inches. So you'd go ahead and cut your steel to that length. This formula is also used for corner bends as well. Matching angles in the corners are a must, and rebar benders do just that. Steel needs to be tied down while it's being placed. We accomplish that by using bar ties, which are nothing more than small pieces of wire about 8 inches long, with a loop at both ends. As you're wrapping the bar ties around the rebar, you'll need to twist and secure the ends with something called a bar tie twister. These twisters are also referred to as a rat's tail or yo-yo.
With all of our steel tied down and in place, we can move on and begin marking the locations for our anchor bolts. Anchor bolt locations are usually found in the blueprints, and when placing anchor bolts, it's a good idea to actually lay out the walls on the form boards first. This way, you'll know the locations of the studs, openings, and anything else in the wall.
Start in one of the corners and begin measuring out. Every now and then, the anchor's location will fall on a wall member, and in those cases, you'll just have to move your anchor to avoid hitting it. Anchor locations can and do get covered with concrete during placement, so it's highly recommended that you mark the locations with a bright color on both the top and sides of the form boards. Red or orange spray paint works very well for marking anchor locations. Our reinforced steel is in place and secured, but we still have to make sure that our concrete slab is reinforced as well. And for that, we can use either welded wire fabric or glass fibered concrete. Let's look at each one of these options one at a time. Welded wire fabric comes in 5x10 sheets or 50-foot rolls. The ends are very sharp, so extra care needs to be taken when handling it. For this northern construction job, the welded wire fabric is positioned on top of the polystyrene, and then the concrete is placed over both. Once the concrete has been placed, a rake is used to lift the wire into the upper 1/3 of the slab. For our southern construction project, we're going to be substituting glass fibered reinforced concrete for welded wire fabric. However, if you're planning on exploring this option, you'll need engineering approval first. Glass fibered concrete is a nice alternative to welded wire fabric because there is in fact no steel involved. So if your concrete develops a crack, water can't find its way into that crack, rust the steel, and spoil the concrete. However, keep in mind that the finish on glass fibered concrete is not nearly as smooth as regular mix and contains tiny fibers that have a tendency to stick out as the concrete cures.
Okay, it looks like our reinforced steel is now in place. All we have to do is check and see if our location needs one final inspection of the steel, and then we can move ahead and estimate the amount of concrete we'll need to finish our job. Concrete is purchased by the cubic yard, and since it's our job to keep waste to an absolute minimum, we're going to need to estimate how much is needed before the trucks show up. Estimating concrete is done by calculating the total amount in cubic feet and then changing it over to cubic yards using the following mathematical formula.
Length in feet times width in feet times thickness or depth in feet divided by 27. Since we already know that there are 27 cubic feet in 1 cubic yard, we divide our total by 27, which changes our feet over to yards. I know it might sound a little complicated, but after you take a look at this example, you'll discover just how easy it really is. We'll start with length using the measurements from our building. Length of the footer is the perimeter of a building. So if we add 65 feet plus 30 feet plus 65 feet plus 30 feet, we get a total of 190 linear feet. Next, we'll take a look at the width. In this case, the width is actually the width of the footer, and it's important to point out that this number needs to be calculated in feet. Our footer is 1 foot 8 inches wide, so we change the 8 inches over to feet by dividing 8 inches by 12, which equals 0.667. So the total width of our footer is 1.667 feet. And finally, we'll calculate our thickness, which is the depth of the footer. When making this calculation, do not include the top 4 inches of concrete in the footer. Those 4 inches will be included in the slab calculation. The depth of our footer minus the 4 inches is 1 foot 4 inches. Once again, we change that number over to feet by dividing 4 by 12, which gives us 0.333 feet. When we add that to 1 foot, our total thickness is 1.333 feet. Let's take these numbers and plug them into our formula. Our length is 190 times our width of 1.667 times our depth of 1.333 divided by 27, which equals 15.64 cubic yards. So our footer will need 15.64 cubic yards of concrete. Let's take this formula a bit further. If our slab is 65 feet by 30 feet, we'd multiply 65 times 30 times 1.333 divided by 27, which equals 24.05 cubic yards of concrete for the slab. Finally, if we take 15.64 cubic yards for our footer and add 24.05 cubic yards of concrete for our slab, the total amount of concrete needed for our job is 39.69 cubic yards, which, when rounded off, gives us 40 cubic yards for our final number.
Once you've finished estimating the amount of concrete you're going to need, it's time to give your concrete supplier a call. But before you do, you might want to check your blueprints first. Why? Because the blueprints will tell you what type and strength of concrete you'll need. Types include regular, pump, or finished mix, and the strength will be given in pounds per square inch, PSI. For residential construction, you'll usually use 2,500 to 3,000 PSI concrete.
Here's something else to keep in mind. Consider placing some grade stakes in the center of the slab. These stakes work really well as screed references and should be placed at the same height as the form boards, and you set them by using a string stretched tightly across the forms. Spraying the form boards with water or a petroleum-based release makes them easier to strip later.
Concrete will usually get to your site by way of a concrete mixing company and will be delivered in trucks that carry 10 yards. Now, we were fortunate that our estimate came out to an even number. However, let's say that your job required 45 yards. Then you'd order up 40 plus yards, meaning that when you place your order, you need to make it clear to the concrete company that you'll have one of the drivers radio the dispatcher about the exact amount needed for that last load. This will give them time on the other hand to prepare that truck. The last thing you want on your hands is a delivery delay, which could result in something we call a cold joint. That's the division created between the set concrete and the fresh placed concrete.
When the trucks begin to arrive, check the delivery chart and see what time the water was added to the mix. Remember, you only have 90 minutes to place the concrete once the water has been added to the mix. Before the concrete leaves the truck, check the consistency of the mix and ask yourself, will it be able to work between the pieces of steel? If it won't, ask the driver to add some water. However, you need to be careful here, because adding too much water will actually weaken the mix. Concrete can cause skin irritation or chemical burns. So, in order to protect yourself, it's recommended that you take the following precautions. Wear waterproof gloves, a long-sleeved shirt, long pants, and rubber boots high enough to prevent concrete from getting into them. As for skin irritation, the best way to avoid it is to wash frequently with pH-neutral soap and clean water. So, where should we begin placing our concrete? I usually begin by placing it in some of the recessed areas, like the garage, porch steps, or the shower recess. That way, these areas will get some added curing time while the rest of the slab is being placed. When concrete is unloaded from the truck, it should be placed as close as possible to its final location. Even though the concrete is mixed, moving it around any more than necessary could cause separation between the gravel and the sand.
Our concrete is finally being placed, but our work is far from over. So let's take some time and look at the tools that will help us spread our mixture evenly and smoothly.
This is a concrete placer, also known as a come-along. It looks like a long-handled yard rake without teeth. As the mixture is unloaded from the truck, this tool is used to evenly spread the mixture across a predetermined area. As the concrete cures, we want to make sure that it has an even, uniform, and smooth finish, and that's where screed boards come into play. They remove excess concrete and bring the top level up to the proper grade. You'll want to use a long, straight screed board for this job, either a 2x4 or a magnesium screed. Floating is one of the first steps towards finishing the concrete, and it begins after screeding. At this point, the concrete is much too wet to walk on, but we still need to reach out to the middle of the slab. And for that, we turn to something called a bull float. A bull float is long enough to reach the center of the slab, pushes down solid materials, knocks down ridges, and levels the surface. A jitterbug is another tool used during this phase of the finishing process and helps to push solid materials away from the wet surface. Once that's completed, we'll use a hammer on the form boards or a vibrator in the concrete to get rid of any air pockets that might have formed around the edges. These pockets are called honeycombs, and we eliminate them by lightly tapping on the forms while the concrete is still soft.
With our concrete in place and leveled, now would be the perfect time to place our anchors.
So I took a lot of the guesswork out of this equation by marking the form boards with orange spray paint before the concrete was placed. Remember, keeping things smooth and even is the name of the game. So as you place your anchor bolts, use a hand float to smooth the concrete around the anchors, and an edger to keep things even along the outside of the form boards. As you get towards the end of the concrete process, you can start removing some of the form boards. Then, use a hand trowel to finish things off as you go. And when the concrete is finally hard enough to hold some weight, you can bring in a power trowel to give a finish to the concrete. Alright, it's time to move on to the last step in the concrete finishing process. And no, there's no fancy tool needed for this job. All you need is a broom. Now, a broom is usually used on concrete that's exposed to wet conditions like porches or walkways. And the broom finish, as we call it, prevents the concrete from becoming slippery when wet. One last word about concrete tools, and that is they need to be cleaned immediately after use. Letting concrete harden on expensive tools will not make you the most popular crew member on the site. And that rule applies to your clothing as well. Indirect contact through clothing can be as serious as direct contact, so rinse out the wet concrete from clothing as soon as possible. It takes 28 days for concrete to fully cure. Now, most contractors can't wait 28 days to strip the form boards, but if at all possible, try to keep the form boards in place for at least a couple of days before stripping them off. Also, it's not a good idea to pry against soft concrete. Prying can damage the finish and chip the green concrete. And when you do strip the form boards, carefully remove the nails and stakes. Protruding nails cause many injuries. Be sure to remove all nails from the form boards and stack them neatly.
With our slab in place, we'll fill around the slab to prevent any washouts and call it a day. Well, that completes program number 2. And as you just saw, placing a slab will put all of your organization skills to the test. So, preparing for this job in advance is your key to success. In our next program, we'll continue our residential housing project with an introduction to exterior wall framing. For Del Mar Learning, I'm Rodney Wiltshire, and I hope to see you back on the construction site real soon.